Hello.
Welcome to LUCA Talk 7, using mobile phone data in transport. My name's Tom Brearley. I'm one of the senior analysts here at Smart Steps in the UK.
And my name is Oscar Garcia. I'm also one of the senior analysts in the LUCA team in London.
Right, so we're going to break this talk down into about 3 sections. So first I'm going to talk about a few of the general principles that we use when using mobile data in transportation. I'm then going to talk about sort of a broader, more general case in which we've applied this in England and the UK specifically, before Oscar goes and talks a little bit about some of the work that Carlos's team in Ecuador has done in a more sort of bespoke, detailed sort of space. Right, so we're just going to change over to the presentation now. So if you just hold with us for 1 second. Cool. Right, so what is mobile phone data? So mobile data is essentially the communication your phone has with the cell phone towers and the cell phone network in order to operate. These communications occur when you're actively using your phone, when you make a call, send a message, browse the web on 4G, or passively as well. So your phone every now and then needs to update itself and check in with the cell phone tower. Also, when it moves from one group of cell phone towers to another, it sort of generates the I'm a moving event. And all of these things for us as analysts generate a data point. That data point says has a timestamp and a cell phone tower ID. And we use that information, sort of knowing the locations of those cell phone towers and the times that you've interacted with them. We can sort of start to make assumptions on where you are and how you're moving across that mobile network. This data is being collected consistently as it's being generated 24/7, 365 days a year. I think we've been collecting it since 2012. And it's being used across the telephone network around the world. It's also worth noting at this point, as though that sounds pretty scary and everyone's tracking you all the time, we at Telefonica and according to a lot of the sort of data protection acts around the world have to anonymize, and we do anonymize and aggregate our data. So what that means is we're not looking at individual Joe Bloggs was here and he traveled to here. We're seeing that a group of users traveled from London to Manchester between these sort of periods, and it really takes a sort of individual personal part out of what this data is, but still maintains a lot of the value that we can use it for. So what does that actually look like on the ground? So if we have a standard journey here, so what we're going to see is a user has started on the left-hand side of the screen at their origin, their home maybe, and they've traveled across to the right-hand side of the screen to their place of work, their destination. And this person in particular has not used their phone as they've been traveling. It's worth noting that with those sort of active events that I was talking about, when you're using your phone and sending texts and making calls, you generate events. But for this one, we're saying that this person has only made those sort of passive events when they've moved from one group to the other. So what we can see here is those sort of coloured hexagons are what we're going to constitute is our cell phone tower network. And the little black dots are places where a user has made an event. So what we can see here is someone starts at home on the boundary of that green hexagon. They create an event as they cross into the green sort of area. Then they move to the orange area and create another event. They then move into the pink area, create one more, and then the final event as they leave the pink area and get to their place of work, they create one more. And these sort of breadcrumbs that we can use to sort of define how someone has moved and where they've gone. In addition to that, if we have someone actively using their phone, we get a much more detailed sort of set of breadcrumbs. Yeah, so again, it's a similar sort of thing where someone's passing from one zone into the other. They're generating these sort of black dots, but sort of interspaced between those, there are a bunch of orange dots, and maybe one of those is someone sent a text or someone's made a phone call, and they sort of drop these little breadcrumbs as they're going along. So what do we do with all that data? So we use that information to help us define sort of where people are settling, where they're dwelling, sort of where they're stationary, and sort of the places where they move as well. So we take all this events data and we sort of classify it into dwells and journeys. So when you're stationary, when you sit at one place for a certain period of time, you're dwelling there. We can say that you've hung around the same sort of cell phone towers for a certain period of time. So it's very likely that you're not moving. Maybe you're at home, maybe you're at work, or maybe you're shopping somewhere. This sort of reverse can be said for when you're moving. So if you're not consistently hitting the same set of cells and you're sort of traveling across the country, there's a very good chance that you are moving. So what we can do is we can say someone they were at home, they dwelled for a certain period of time, then they started hitting cell phone towers sort of further away from their home in sequence, and then dwelled somewhere else at work and stayed stationary for a certain period of time at work. And what we can do with that is we can start to build up sort of a network of how these people are moving across the day. So maybe you started at home at location A in that little diagram, then you've moved to a different location, C, then you've gone to D. And we can sort of start building this picture of how not just this person's moving, but how the whole population of people under this within our data set, in the cell phone sort of data set. Further to that, there are a whole bunch of insights that we can sort of glean from this data going a bit further. So there's information that you can pull off sort of the contract sort of information and stuff like that. So when you sign up for a new contract, you have to put your age and gender down. We can do a bit of an inference looking at how you're traveling when you're doing those journeys to determine the sort of mode that you're taking, looking at where you're staying and what times and stuff. We can derive if you're at home or at work, how often you're traveling, and which route you're taking. So there's a whole bunch of different things that we can sort of go into with this information. It's absolutely massive. So now I'm going to just sort of step back a little bit and try and put it into more of a context and how something like this is actually used in practice. Now, I mentioned before that I was going to talk about a more sort of general solution before Oscar talks about a sort of more bespoke, detailed solution. So the project that I'm going to sort of walk through is the trip information system. Now, we developed this project for Highways England. So Highways England is in the UK, is the government company charged with operating and maintaining the England's motorways and A roads. So they came to us looking to solve a problem. Their problem was, as a government body, a huge part of what they do is deciding when and how to invest their budgets on their road network. They need to know, do we decide to improve this road or this road? And because they have a somewhat limited budget, it's really important that they make the right decisions on where they're spending that sort of money. That's absolutely crucial for them. And a core part of what helps make those decisions is the origins and destinations of where people are starting their journey and where people are ending their journeys. It's really important. For example, if you've seen that, so we've got an example town in the UK, so town A. Every morning and every evening, the main road through this town is absolutely packed, and you're considering fixing it. If you have the origin destination information, you can see if people are the locals traveling within their town and they're just trying to get sort of a little bit across town from their home to their work, or if they're travelers passing through. So if you look at the top left, there's a little house there, and there's a little work there. So are we sort of worried about the people that are moving just within Town A? Or are we worried about the people that are actually just using Town A as sort of a means of getting from one place to another? And that's really important. That's the sort of information that could be the difference between maybe just adding a few lanes or just widening the road within that town, or even creating, building a new bypass to sort of cater for those people that are traveling sort of through that town rather than within it. So traditionally, the way that this is done is the Highways England will come in and they'll commission a study to say, we want to know how people are traveling. And they might get sort of origin destination information from things like automatic number plate recognition, roadside interviews, there's Bluetooth as well. But while all of these are fairly accurate, they all have a big limitation in that they're only going to be very localized sort of sources of information. So for roadside interviews, which is a very common way of doing this at the moment, you have to set up a roadblock at either end of your town, stopping people and asking them, where did you come from and where are you going this morning? And that, first of all, that has a huge impact on if you're coming from somewhere else to somewhere else, maybe you're going to physically avoid that part of town because you don't want to be you don't want to be stuck in traffic for a morning. So this is where mobile data comes in, and we can do this without sort of impacting anyone on their journey to work, their travel, or anything like that. This is just being collected passively, and we can provide this information fast and effectively. So what have we done for Highways England? We've built this web platform. And this web platform allows Highways England sort of employees and their contractors to come in and get that origin destination information. So we've created the system that lets these people come in and choose what data they want to get sort of specific to their area of study. So if we're looking at a bypass study like this, we might only be interested in what is affecting this small region. So this system is super customizable. It can be split and sliced, focused in any way it wants around sort of England, Scotland, Wales, across the whole of the thing. So you can start to create a picture of what your region is specifically, and that's going to be very sort of comparable to any other study that's also done using this system. We've also maintained that because this is part of the transport industry, it very much needs to have a high quality, and we've gone through a whole bunch of validation checks and things like that. This means that when the user comes in, they know that this data has gone through the set of checks that they're aware of and they know, which means that in turn, we can turn around this sort of information really, really, really quickly. So I'm just going to spend a little time going into the system. This is going to be a really short, brief overview, but this is a live system that Highways England is able to use. So like I mentioned before, they can come into the system and then they can sort of play around, and maybe they want to do a new study. They can go in here and create a new study. And we've got all these sort of drop-down menus that give a huge amount of sort of customizability for what the user actually cares about. So they can select weekdays only. We want this date range here. If we wanted to look at maybe instead of this date range here, we wanted to identify maybe what is the traffic like in January against December, then that's definitely something we can do. We can also go into all of this thing, looking at how we can slice the data in different ways. So maybe you want to know how the that sort of travel pattern changes across the day, then that's absolutely something that the system can cater for. If you wanted to swap between road and rail, also, again, we've added all of this functionality to make it sort of as open as possible, but as well as maintaining that really high quality of output. So we've had a look at that. I'm sorry that was quite brief, but we've shown quite a sort of broad way of providing an open-ended system in which we can extract origin destination information. Now Oscar's going to jump in here, and he's going to talk about a much more bespoke sort of detailed project, and I'm going to pass over to him now.
Hello, as Tom said, I'm going to talk now about a bespoke project that the LUCA team in Ecuador developed in the city of Quito, and this is a transport plan project for the city of Quito, as it said. In the metropolitan district of Quito, there are 2.5 million people living there, and they are divided in 65 different parishes. And in the last few years, the city has seen an expansion of the transport system. First underground line is under construction and is going to be open next year. Also, there has been an expansion of the dedicated bus lines and a complete restructuration of the transport system. And the last mobility study in the city was carried out in 2011. So considering this, a new study was needed in order to have updated information. In this project, we are using the macro network data. This is our main source of information. And using this data, we are extracting the origin and destination of the journeys, the date and time, the journey frequency, the mode of transport, and also the journey purpose. But on top of that, we are also using a series of personalized messages, text messages that are sent to a huge number of Movistar users in Quito. And using this SMS, we get information about the education level, duration of the journeys, and also some supplementary information about mode of transport and journey purpose. And those two data sets can be linked together. So this is the study area, which is Quito, the capital of Ecuador. The area we are selecting is the city itself and also some neighborhood towns. Now I want to compare the old survey that was carried out in 2011 with the new study that we have done using the mobile data in 2016. In the old survey, the sample of people that was used, it was 60,000 people, while for this project we are using 1.5 million people who are the Movistar users in the Quito region. Apart from that, as we are getting much more as a much bigger sample, we are able to be more granular, and we are dividing the area in 700 zones, while in the previous study they only used 272 zones. And also, the use of this technology makes it easier to use a larger amount of data and bigger samples, as I said. So we are analyzing one full year of data compared to 1 day of data that was surveyed on the previous study. Also, we can be much more granular using the time periods. So we have divided each day in 7 different time periods, while previously it was done using just 3 time periods. So as you can see, the improvement in the quality of the data we are dealing with is quite important, and we can be much more granular and consistent. So now I'm going to show you a couple of case studies that we have done in this project. This is just a sample because we developed some few more case studies, but this is depending on what the client needs, so you can do one thing or another. So in this particular case, I'm going to show you the traffic density calculation by Paris. So the first thing we get is all the journeys that are between all the different parishes in Quito, the 61 we saw before. So we are getting the journeys starting and finishing in each of the parishes, and we know where they are going to and from. Then we calculate the routes between all the parishes, and we can transfer the volumes we got before to these routes. And also, by matching these routes to the road network of Quito and knowing the number of lines in each of the road, we can calculate the density of traffic in each road And at the end, what we get is a map showing the density of traffic by each of the parishes in Quito. And this is an important tool that the local government can use in order to determine whether to focus to improve roads in one area or to build a new public transport line. Here, how the busiest part is the central part of Quito and also the north. So the local government can use all this information to their needs. Another small case study is to analyze the visit to specific areas in the region. So in this case, we are analyzing the people that are visiting the historic center of Quito. Here on the left, we can see how the different numbers of people visiting the city center by hour of the day. This is just an average normal day. So, and we can see how there is a big increase in the number of visits after 6 p.m., which is when people have finished their work, so they go to the city center before going home. And on the right-hand side, we have the number of visits by spending power. Spending power or affluence is how wealthy people are. And to get this information, we are using a series of parameters like where people live, how they travel, how often they travel, the type of terminal they are using, the type of contract they have with Movistar, and some other variables. And we combine them, and using an algorithm, we get the affluence value for each of the users. We have 5 different ranges, being E the lowest one and A the highest one. As you can see on this graph, the population of the city center of Quito, the affluence is not very high, but the affluence of the people visiting the city center is much higher than those living there. So it means that people are visiting the center from many different parts of the city. And also knowing the affluence of the people is important to know or to adapt the policies, or like, for example, you want to adjust the prices of the parking spaces, or it can also be used in retail. So you are knowing the type of people that are visiting retail or small shops can adapt their offer to the demand they are having. Powerful, and these insights can be much bigger depending on the client needs. Now I'm going to show you another case study, but in this case I'm using a web dashboard. So this is a dashboard that was developed in Carto, and you see here the city of Quito. We have several layers on the left, like the population of the different areas, the 700 areas we are analyzing in this project. Or we can also use the density of population. So this is just to have an information of the background of the area. Then this is a layer with the tube line, the underground line that is being built, and all the stations that are there. And also we have here the influence area of those stations, and it has been calculated that in the future, when the underground is open, around 80% of the people who is using the underground are coming from these influence areas. So we can use here on the right, and we can select some stations. Like I'm going to select the underground station in La Carolina, which is a very popular area in the center, which is there. And I can show you there these lines, the green lines. The darker the line and the thicker the line, the highest number of people that are moving between those 2 points, and the lighter the line and the more clear the line, the less number of visits. So this is important to know the potential use that is going to have a particular tube station in the line. And also you can select here the routes. These are all the routes between the different zones that we have calculated. And the darker the color, the more number that are at the moment traveling through those routes. So this information is also important in order to increase the number of public transport lines between the zones with the highest demand, so they can connect better the tube underground, the tube stations with the areas in the city. So now I'm going to show you different information we have in the map. So here before, the purple dots are the stops of the bus, the trolley bus. So, and those 3 lines here are the main public transport lines in the city, the 2 existing trolley bus lines and the future underground station. And also, in this other map here, you see, we have the number of journeys between all the different areas in the city. And again, the same, the darker the line, the more demand we have on that line. And this information can be used for the local authorities to determine and to detect where are people moving the most, so they can adapt the policies related to public transport. For example, you can see here how we have a good bunch of very thick lines with a lot of connections and a lot of journeys, and we may think that this is an important area to put a new public transport line connecting the city center. But if you look a little bit closer here, you see how there are not many journeys between this area and the city center, because all those lines there are quite thin. So it means that people here are making mainly intra-zonal journeys rather than extra-zonal journeys. But on the contrary, if we focus the view here in this area, we are seeing that, yeah, they are still making a lot of intra-zonal journeys, but also they are making many journeys connecting with the city center. And on top of that, this area is not covered with the trolley bus or the future metro station. So it makes this area a good place to put a new new public transport line. So this is just a small example of the information that the local authorities, without having a look through boring CSV files or something, can get from this dashboard. And the information we put in this dashboard, it can be updated depending on the client needs. So it's up to the client what we show to them. So, before finishing, on behalf of the LUCA team in Ecuador, I'd like to thank the municipality of Quito and the Inter-American Bank for giving us the opportunity to develop this project. I hope you have enjoyed the webinar. We have seen general situation solutions for large areas in the transport system, in the transport information system that Tom presented, and also bespoke projects like this one of Ecuador that I've just talked about. And we have had the opportunity to see how powerful the solution of LUCA Transit is to carry out transport-related projects in comparison with traditional methodologies. Thank you very much for being there. Now it's time to answer some of your questions.
Okay. Can we put the camera back on? All right, one moment. Let me just, might have to turn off the screen share. There we go, cool. All right, so as we've been going through, we've had a few questions come back. So just going to sort of go through that as they come in, more or less. There we go. So the first one from Ben J2508, you mentioned it is anonymized. So what is the smallest number of people you group your data and report? Okay, so that really depends on sort of the country and the data regulation and specifications in those countries. I can say in the UK, we stop at 10. So if we, in our analytics, if we identify sort of a grouping of less than 10 people, then we sort of have to start rounding and things like that. So we will never go under 10. But yeah, as I said, that depends on the sort of the country and things like that. Right, Oscar, do you want to take that second one?
So Anne Crystal is saying that great stuff, thank you. So just wondering what constitutes as dwells, how much time do people need to be in one specific place? Well, in general, in this project for Ecuador, they were using dwells with a duration of at least 30 minutes. So, and it's the same amount of time we use here in the UK, I think. So when people stay more than 30 minutes in one single place, we consider that a dwell.
And that there is a little bit dependent as well, project to project. There's also other ways you can look at doing dwells and things like that. But generally, I think we run at about 30 minutes as a good sort of, you've stopped and you continue. Right, so I think we can answer Simon and Rishabh's question. So Simon and Rishabh are asking about getting access to this data. Simon is asking about is this data available for researchers in academia? So we've so there's two answers to that question. So first answer is LUCA has this sort of, what do you call it? They have doing this thing called big data for social good. So looking at sort of giving back to the community on with the big data that they have. And that's something that if you've got a project idea or something like that, that you think could be really beneficial to sort of society and things like that, then that's definitely a conversation that I'm sure a few members of our team would be happy to talk about. In the UK specifically, I think it's under Transport Systems Catapult. They're doing some things looking at providing mobile data to sort of for research purposes and stuff like that. So if you want to look into that or talk to me again, or Oscar for sure, we're more than happy to sort of talk through it a bit more and exactly get your ideas on what you want, what you're trying to get out of it.
Okay. So Rishabh is also asking, how did you introduce spending power of people with mobile data survey for Quito City? Well, if I understand the question well, spending power here, it was extracted in order to give the customer, which is the Quito local authority, the biggest number of insights to them. So we split the data by demographics, so they have more information about the type of people who are moving, or if there are any differences depending on the spending power of the people. So, as I said, is something that we are calculating using a series of variables that are extracted directly from the mobile phone data, and using an algorithm to combine those variables, we assign those values of spending power to the different users. But the use that the client does with that information, well, it's up to them. But it's important to know the kind of people and how affluent they are. So because you can modify your policies, or you can also change how you approach a problem depending on people, the band they are.
Cool. Also, do you want to say the next one as well?
TY7002 said, hi, had Quito used this information to optimize transport in any way? Well, this is a project that has been delivered very recently. So it's been less than 2 months, I think, that since it was delivered, or maybe even less. I'm not exactly when, but it was this summer. So I don't know exactly how they have used it yet, because it's been a very short time. But yes, the client is the local authority of Quito. They are going to use it in order to adapt the transport policies in the future, and also as a good tool in order to compare how people are moving before the opening of the underground stations and after the underground stations are open, because the idea is to carry out with these projects in the future. So you can compare how transport is evolving.
Yeah, no, definitely. And that'll keep evolving as well. So I think we've got one last question, which I was asking again. So how to identify the direction of the journey? It's a little easier. So we know, so as I mentioned at the start, we know the locations of the cell phone towers. We know what time you've hit them. So if you're hitting a more southernmost tower and then a more northernmost tower, then there's a very good chance that you were traveling north, going up the country. Same could be said if you hit a more westernmost tower than a more easternmost tower, then you're very likely going east. Cool. Oh, we've got one more. Do they have tests in Mexico about the coverage of telephone information?
Yeah, not sure about the projects that have been done in Mexico. So we'll need to ask the specific thing there, because at the moment here in LUCA, London, we are mainly doing projects for the UK and also some projects in Spain. We have been in contact with people from Ecuador and other parts of South America, but not Mexico recently. So
if you'd like more information on that, again, ping us a message and we'll be more than happy to put you in touch with the right people for sure. Right, so I think that's about all for questions. I think, do you have anything more to add, or?
Well, just before leaving, I just want to remark again what Tom said about anonymity, because this is an issue that many people can think about or they can be concerned, but just to remark that everything we are analyzing here is completely anonymized, and then the data is aggregated and extrapolated. So, and we are also rounding the numbers, so no information about single individuals is given. So people have to be quite confident about that we are not dealing with their data or with their position. We are just analyzing users as a group, as a whole.
Sure. So I think that's all for us today. Thank you everyone for tuning in to LUCA Talk 7, using mobile data in transport. It's been quite fun. It's been quite good. I hope you learned something. And thanks again for coming along. If again any questions that you'd like to ask in person, I think the LinkedIn's for you and I are on the description.
Yeah, in the description of the webinar, there's a LinkedIn link to our LinkedIn pages. So you can contact us if you want, or send an email to, I don't know if you haven't. Somebody else.
Cool.
Okay. So thank you very much for being there. It was a pleasure.
And we'll see you guys. We'll be partaking, maybe watching the next LUCA Talk. So hold out for when that one is put on next. Thank you guys again.
Thank you. Bye-bye.